Okay, I'll go with Marty. I am from Brooklyn, so Marty's close enough. What I want to talk to you about this afternoon are the dramatic changes that are occurring in our industry. But I want to offer some challenging thinking. So I'm going to make some statements, like, for example, I'll make it right now. Software development as we know it and as we do it today is going to go away. It's impossible in the future. I'm going to present reasons why. The challenges we face are different than ever before. Software is complex, systems are complex, and what we're trying to do is very complex, and that's all true. I think we all buy that. But now build on top of that, that businesses have to change on a dime. Everywhere. Unknown today even. And after that change, they have to change again. So what is VANTIQ? VANTIQ, we're a software company. We have a software development platform for the types of challenges that we see today. Company was formed 3 years ago. I've been in the industry 30 years, and I think these challenges I'm talking about are worse now than ever before. So, businesses, we've all seen slides like this. I just want to approach it from a slightly different angle. Okay, lifespan of business is going much less because of all this technology, all this change, and there are new players, there's fintech, there's Amazon, et cetera, and you better act quickly. But there are a couple of other phenomena happening. One is the actual structure of businesses is changing, and it's going to change dramatically. Who knows what GE is eventually going to look like? Those economies of scale are no longer there. Globalization and global supply chains change everything. And then the way people are informed and able to do things adds a further change. Well, the agile businesses maybe will last. But there are a few requirements. I'll talk more about the technical ones. Obviously, business strategy, and the right one is critical. And I'll talk about some of the ways that that particular problem can be reduced. But first, let's look at all the technologies we have. Now, this is meant to be a little humorous. Cloud revolution. Coming cloud revolution, smartphone revolution, IoT revolution, AI revolution, microservices, DevOps revolution. Technologies never changed as quickly before, and yet almost all of these technologies are critical and will be utilized in the very near future. They all have their own easy ways of doing maybe the cloud, easy ways of doing maybe AI. But when you put all this together, the challenges are daunting. And the other problem is change is accelerating. So if we look at the architecture of systems that were built basically through almost all the time of computing, it was always a three-tier architecture. In the 90s, I was CEO of a company called Forte Software, and we had the pleasure, really, of introducing client-server computing for the internet. And we had home banking systems, New York City's 911 system, EasyPass, et cetera. These were mission-critical systems that were no longer on the IBM mainframes, on the CIC systems. They were innovative, but it was the same architecture. And if you look at Amazon today, not AWS, but Amazon itself, the architecture is the same. It's a server, it uses AI, lots of information on customers, but it's a physical three-tier architecture: database, server, and front end. Now let's look at today. This will happen. The businesses will be operated in real time, the whole business. And the underlying technologies to enable this have to change. In fact, the underlying technologies to enable this aren't even there yet. Gartner talks about ENS, the Enterprise Nervous System. That's one of them. Other concepts out there like event storming are coming to fruition. That's another one. But these new technologies that really aren't even being used or haven't even been created yet are the means to get us to use all of these technologies. Because there's one critical word I want to point out there. Operate the business in real time. And real time means IoT, AI, NLP, smartphones, of course. And real time also means that the number of things happening is going to go up exponentially. So, what do these systems consist of? Software, of course. Where is the software going to run? The software is going to run everywhere. Back 3 years ago when we formed the company, it was interesting because if you spoke to the industry analysts, their comments were, or their thinking was, everything goes to the cloud. We have these new cloud computers, Fitbit to the cloud, we'll analyze it and we'll take action there. Edge computing was not even talked about 3 years ago. That's how quickly things change. Just starting to with Cisco and fog computing, et cetera. Now, it's strongly talked about because it's required in many cases. In fact, if you follow 5G and these MEC networks that are going to be coming out, they are distributed computing environments. And if a car wants to speak to other cars or traffic lights, that has to happen locally. Can't go to the cloud. And so we're talking about data centers everywhere. In fact, I was with a company just a few days ago, very large Japanese company that's producing what I call cloud in a box. Basically, it's probably the size of a shoebox with hundreds or thousands of processors. It runs OpenStack, which basically allows it to be a cloud-based environment. And you could physically, and it's low power, so you could physically put it almost anywhere. That means that the whole definition of what a cloud environment is going to change. I was just recently in China. I visited 25 companies there, and I couldn't believe how many of them had their own cloud and using things like OpenStack for either subsidiaries or customers, et cetera. So that's another trend too. It ain't going to just be the big guys. As much as Amazon and Microsoft would love to think that, there are going to be other types of technologies out there for computing resources. And eventually, it's going to be much larger than the clouds that we currently deal with. And that's part of our infrastructure. Next big change is sensing the world, IoT, if you will. And here, too, we all know this, change is going to come upon us quicker than ever. But there are a couple of anecdotes I want to pass on. I was in Japan recently, and the government there dictated that RFID tags are going to be on almost anything that identifies the widget that's being sold. It's electronics, if you're not familiar with it. It could be put on anything and then tracked wherever the asset is. Now, when a government dictates that, you know it's going to happen. And that's going to change asset tracking, theft. I'll talk about that in a few minutes. In China, the government dictated that 5G is going to exist in 2020. And this isn't independent companies like Verizon or AT&T doing it. They're partially state-owned, and they're going to move there like that. And that's a distributed computing environment. And the reasons, sensors are going to be everywhere. So if there's a city, for example, and it has a 5G network, the cost of the sensor, $5, $6 with a SIM card, maybe measuring water pressure or air quality. Well, why can't a decent-sized city put 20, 30, 40 million of those out there like that? The cost is not that great. And for security reasons and others, it's going to happen. So IoT is really starting and it'll be pushed as the networks are able to support it. Now, here's another area, an area that's often too often ignored: human-machine collaboration, getting humans involved at the right time. These systems are going to be so complex. And then if you talk about systems working with other systems, only humans can be involved at key points. In fact, I would argue that we talk about jobless, businesses because of automation. I would argue the opposite. I would argue that there is going to be so much new technology that is going to do so much more than we think of today or even envision, that humans are going to have to be there in the loop. We're starting to see signs of that today, and I'll talk about that in a few minutes. And then services. This is kind of a blessing for us in our industry. You can get information on almost anything. Go to the programmable web. The last time I looked, there was 18,000 APIs. You can find out diseases in what areas, find out weather, of course, but there is such a vast variety of information that you have access to. So, if you want to operate businesses in real time, you have to include all of this in an intelligent way. You're going to have IoT, you're going to have people involved. Software is going to run all over the place. This is a highly complex environment that we're moving into. So to support what I said before, do we need new tools? Absolutely, we need new tools. Now, of course, I'm a software company that creates these new tools, and we target this market, but we won't be the only ones. There'll be others too. The way to develop software is going to change, and it's going to change very rapidly. We're already seeing it in some of these products that call themselves low code. Might be in this environment, might be in that environment, but that's a trend that is going to have to pick up a lot. Now let's talk about the enterprise and how the enterprise works with all these technologies. First thing is, when you develop an application, you're developing an application, it gets inputs and outputs and so on. But really, these new systems are going to be networks of applications. For example, let's define a business event. Business event might be there's a camera up there and it takes it knows who I am, does facial recognition, recognizes me. That's stored in a database and stored as I'm the keynote speaker today, I'm authorized to be here, etc. Let's use employees as a better example. It says that I am an employee of this facility, I have the right to be here, it's during working hours, and so on. Once you define that event, wouldn't you want to reuse it again and again and again? If there's a security problem, for example, we don't know who's here, why not reuse that event and see if that person talking is on the FBI wanted list? That capability, and you could think of lots of examples of that, to be able to define complex things that happen, complex real-time events, and reuse those real-time events is an absolute requirement to create much more simplicity as we move to this complex environment of everything being interconnected. And those technologies are not yet in the market, but they soon will be. Where will the software run? It's going to run everywhere. A simple example, elevator system. You could have local control, variable floor scheduling, and adjust the routes depending on meetings, etc. And supposedly you could decrease the number of elevators by 10, 20% with these elevator systems. But the analysis, the machine learning algorithms, run in the cloud. So here's a simple case of why things need to be distributed. And as we allow for that distribution, specialized functionality can exist in both places and can be changed from one place to another. How does the software get there? We're all familiar, I'm sure, with containers and other current means of distributing software. Powerful. But the problem is a little more complex than that, because the problem is what software? What pieces are going to run where? What's going to run in the cloud? Or that cloud lit, that box in the cloud that I facetiously mentioned earlier. Maybe they'll take that name. It would actually be good marketing, in my opinion. Anyway, how does the system decide which logic runs where? Okay, programmers, developers. What happens if it doesn't work for performance reasons, security reasons? Developers have to change it. Why not have operations people change it? Or even better, why not have the system itself change itself? System says, this isn't working, the aggregation I'm doing in the cloud is taking up too much whatever resource, I'm going to move that aggregation to my edge computers. I said, the system will do that. The system can monitor itself and readjust what's where. Now, you're not going to go crazy and do that with everything, but there are some key areas, such as performance or security, where it could be very important to make those changes. So we're working with a large railway system in Europe, and one of their requirements is cloud-based, but also they'll do, I assume, billing and tracking of people and tracking of assets. For security reasons, in their many thousands of stations, they want the software to be able to run there when required. So it goes up to the cloud, but if the latency to the cloud gets extended or the cloud availability isn't there, they don't want to stop the whole system. Another company we're working with, Israeli Electric Company, for security reasons, is also looking at having logic located in different places, and the logic, well, first people can change it, what runs where, but also the system can change itself. And you could guess and if you spend some time thinking about, think of how beneficial that could be in an attack situation for cybersecurity. Break up the network, give some support to the local places in the network. So, how will software get there? It ain't an easy problem. You could put it there today, and then you might have to change it tomorrow, day after. You might have to change it quite a bit, and maybe get assistance from the system into what runs where. Now, this is not, I mean, a lot of logic, we know exactly where it runs. PLC logic runs near the machines, one hopes. But this is more for the business logic, how you're running and executing business functionalities at a high level. Okay, this is the necessary Gartner quote. Next generation digital business applications will require effective human-machine collaboration. 3 years ago, when we formed VANTIQ, we were talking to the wind, really. Nobody was listening to us about human-machine collaboration. That has snuck into the vocabulary very strongly over the next 3 years. And for the reason I said, these systems are going to be so complex, and sometimes unintended consequences can occur. Imagine when you really do tie a smart city together, and you have the sewer system, and the water system, and the air systems, and parking systems, and traffic systems. I can almost guarantee you something will go wrong when all of this data is tried to be looked at together. What do we do then? Build an AI system that addresses it? No, I don't think so. That needs cognitive AI. AI is great in narrow fields for what it does. It's fantastic for what it does, machine learning, etc. But the complexities of the systems that we're going to be developing, once we start tying them together, these complexities are going to require humans to be involved. We don't want to happen what happened in Jurassic Park, where the system just kind of took over on its own, and there was no way of curing it quickly. So, man-machine collaboration, major direction over the next decades. This talks the same way that, this professor of computer science says people have to be involved with AI. Okay, now why? Here's an example of a jet plane. Jet planes are very complex systems. They have, 40, 50 different systems there. But the human-machine interface has evolved over time. Over about 20 or 30 years, they were actually just 20, 30 years ago, the systems were much simpler. And the system knows how to communicate with the human. It has something called a stick shaker. If the plane is going to potentially crash, the system knows that and tells the pilot to pick the nose up so a stall doesn't happen. There are all kinds of sounds, traffic, pull up. Then most interesting, many of these systems work together. So obviously I'm a pilot, so I know this. If you're flying at altitude and there's another plane coming at you and it's 2,000 feet below you, and you're both flying like this, no problem. But if you start to descend, then you have two separate systems that need to work together. The vertical speed indicator, saying you're descending, and the communication systems between those planes to know where they are, or even potentially radar. So you have multiple systems working together, very complex. Point I want to make is it took 20, 30 years to get these systems to work efficiently. You don't have that much time. If you buy into my argument that these systems are going to start to work together, then right now we got to start thinking about when to include humans. And in the design of the next generation of applications, I would argue that's one of your biggest challenges. When is the human involved? When there are problems. What types of problems? What about unknown situations? How do you define them? How do we get a human to say, okay, this is okay? So a new level of complexity. And what's needed there are easy ways to communicate with humans. There's the crew awareness system in a plane. Just basically a few different color lights. We have the power of this guy. And a lot more information can be communicated to humans when things go wrong. But we don't use it in business. Very rare usage. And I'm not talking about email or Slack or SMS. I'm talking about integrated into how you run the business. But they will be. And tools are needed to create that type of functionality. So that when, say, a technician is doing something out in the field, the technician is assisted by the computer. The computer knows the state. It has sensors, it knows this valve's working, this thing is not working. The computer could make recommendations to the human. Okay, this type of problem from machine learning, we know here are the 4 recommendations you should follow. 1, 2, 3, 4. But the human knows more. He's been in this situation before, and he says, in this particular situation, with water on the ground or something else will cure the problem. And then he does, from his experience, what cures the problem, and the computer observes it through its sensors, and they're collaborating. That's a form of true collaboration between computer systems and humans. And these are the kinds of systems that need to be developed. Also, collaboration of humans with humans. If a technician is out doing a repair, there should be a whole bunch of other people that he can immediately call. And I'm not just saying call, it could be interactive, could be SMS, or it could be through the system recommending who's available right now, who he should get in touch with, and if that doesn't succeed, escalate it to somebody else. So true collaborations in real time between multiple people in an organization when the problems are more difficult. Now, I spoke earlier about complexity of developing these systems. So to get around this, we need true low-code environments that are in the agile development and DevOps framework. A lot of buzzwords there, right? What we really need is the ability to get software developed like that. So here's an example of a collaboration built in our system. It was built in a couple of hours. And what is it? It's the interactive part of the Uber app. 2-3 hours. There's an assignment that says, find a car within 1 mile that is this type of car that's available right now, that will go this distance or not work too long, etc. One box, one rectangle on a screen. Another one, track that car in real time until the car gets to its location. If it doesn't, do something different. When you can create abstractions like that at a very high level, software can be developed much quicker. And if the abstractions are reasonably general, then it could apply to very different types of applications in very different industries. And it turns out, from our experience, they are pretty general. Because here's another one. This is a company from Chicago who chose to get into a new business in the gig economy, basically hire technicians on an as-needed basis. It enables them to, for example, open up offices quickly in places where they weren't before. They repair heavy equipment for very large manufacturing companies. And they have thousands of people, but this way they could respond to the market without hiring thousands of people. And this system is up and running and in production. That's the system, 90% of it. There is some coding that had to be done, 10%. So can software that's reasonably complex be built a lot easier? The answer is yes. And the requirement is it has to be. And it's not just the development of the software. It's once the software is developed, what about change? Okay, a couple of things to think about. I'm on the road half the time at least. I've been in Asia the last 2 weeks talking to companies like their equivalent of Amazon, Airbnb, etc. And the innovations, especially in China, that I'm hearing about are pretty mind-boggling, actually. Maybe even a little scary for us. But they will be probably the first to enable things to be delivered like that through multiple mechanisms. Could be drones, could be cars. Other systems to get things, because who doesn't want what they want right away? Mankind does. If you can get it quickly, and they can do it, why not? Transportation logistics. What about thinking through, I want to go from A to B, and there's a combination of trains, planes, Uber, and if I'm in a train station, I get off at one track and I have to go to another. Why not use AR, augmented reality, to guide me to where I have to go? Some of these train stations are really complex. So you're walking around saying, okay, walk up to the stairway, go down the stairway, train's leaving in 3.5 minutes, there are empty seats there. This is not far out in the future. This system, I was actually talking to a system integrator who's going to be building something very much like it. Next one, design. Why not design something once and choose it the way you want it? We've all heard that one, so I'm going to skip it quickly. How about theft? We are not that far away from where theft is almost going to disappear in the corporate world. Now think about the savings when that happens. How many trillions of dollars around the world per year will that save? And why is that going to happen? Because of identification of humans. Unless robots start stealing, that's still who are behind the stealing. We could recognize who is where, what, when something happened. And that is going to happen through camera technology and other technologies, through facial recognition, retina recognition, who knows, possibly even using, sense of smell and other senses. But that will happen. We'll know where every employee is at every point in time. Again, in China. China, and it's not necessarily a government dictate, but what they're going to do is they're going to monitor everything out in the streets, at public places. So their goal is to reduce crime to almost zero. In other words, you're going to get caught, much more so than the UK does, which does a pretty good job of this right now. And what does that mean? Very advanced uses of technology and very, very interesting uses of collaboration. Because when you identify a human, who are they, where do they work, are they a threat? Should we call 911 immediately? I mean, these systems are going to all be integrated. And the crazy thing is, this is not too far away. I'm listening to them talk about this stuff. And other security, for example. One of the innovative ideas I heard was kind of a two-factor authentication for starting or stopping or changing machines on an assembly line. So the way it works is you have all the security built into the phone, which does facial recognition, stuff like that, but it's still possible that the phone is being used by somebody else. So the second factor authentication is a camera does separate facial recognition up on the wall and says, okay, that is Fred, and he has that authority. And then he can make the change. The types of systems that are being contemplated right now are so far beyond what we've thought of just a few years ago. And guess what? They're going to get much more complex, and who knows what we're going to be thinking of in just a few years from now. And then moving around. I kind of gave the story of traveling in the trains and moving from one train platform to another. The system will guide you, tell you the time, etc. Intelligent assistance, and that'll occur everywhere. Okay, so let's kind of summarize this. First thing is we're in for more change than we've ever seen before, and that's exciting times. Second thing is this change is going to occur quickly, quicker than we realize. These guys have been around for 10 years. Everybody has one. What's going to happen to them in the next 10 years? They're going to be totally integrated into the way businesses operate because humans are going to be integrated, and this is, of course, how you communicate with humans. Businesses are going to move from the current type of structure, which so much of their operations are done in the background, done in batch, to real-time operations where they can, where machinery can operate much more efficiently and much quicker, maybe requiring new types of machines, new types of robots, and we all know that's happening already. Agility in DevOps is a must. And I'm going to make a very general term here instead of either agility or DevOps. There has to be a new way to develop software. The old ways ain't going to work. I don't know when it was. I think it was like in the 1950s where somebody said that in order to do all the telephony, to all the calls, when it was hand done by humans, that would be required in the next 10 or so years, every high school graduate would have to be a telephone operator. But we're getting to a situation today with, if you got all this software is going to be built and connected together and working together, every high school student is going to have to be a software developer. That's not going to happen. So we need new mechanisms of developing software. Abstractions are a solution. So I gave you the example of collaboration. I showed you that little Uber-based example. Whether it be us or some other company, developing human interactions easily is going to be an absolute requirement, and automatically generating the code and worrying about the recovery, the distribution, etc. Productivity will be orders of magnitude faster. And we're not talking about collaboration. So Fred wants to call Sally and she's not there, he calls someone else. We're talking about collaboration between complex systems and multiple people in intelligent manners. Next thing, places. Software is going to run everywhere. The logic's going to be located on the edge, in the cloud, and very importantly, it's going to move around, so prepare for it. You might put it in the cloud today, and for reasons of security, performance, move it to the edge, or vice versa, or split up among different edges. You could almost think of software as a traveling asset, and sometimes under its own control. Now, it may not have to physically move. It may be turned on and off, but same basic effect. Things. Everything's going to be monitored, and event-driven real-time is here to stay. I hate using the word complex event processing, but complex event processing was a very successful way of dealing with basically financial transactions previously. Worked great. It's similar types of things that are needed for how we're going to run these businesses in real times. And that requires whole new technologies under the covers. If you've heard of something called reactive programming is a requirement in real-time business because what it does is it doesn't block. All calls, all asynchronous calls are handled as they come in. And there are technologies like that that will enable high-end event-driven systems to be built because whatever you build today, it's going to grow like crazy if it's successful. The systems, as I said, they got to be scalable and reliable. So, are we in for some changes? I think we're in for some dramatic changes, but it's also kind of exciting. And the companies that could take advantage of utilizing these technologies, that can really use AR and AI and machine learning and facial recognition and sensors everywhere monitoring everything, and then keeping people in the loop as required, are the ones that are going to be able to build the next strategic systems for tomorrow. They'll be able to work with the business people to think through, maybe we can really do this today. Let's try it. And if it's done in a very rapid development way, a very low-code way, let's try it today, see how it works, change it tomorrow. Okay, so I hope I tried to make it a little more interesting than the standard IoT pitch. Trying to put a little bit of future flavor in there. A lot of what we're talking about is going to happen, and you need to be prepared for it. And it's how you develop software today that is going to be critical because you don't want to create a legacy system in a week. You want these systems to be flexible. Okay, thank you very much.
We were going to see if there. Oh, hello. We were going to see if there are any questions in the audience for you, Marty. Questions? There's one in the back. George, hold on. Do we have a mic for George?
George McQuillister, PG&E. Curious to know, can you offer any insights or observations in terms of how do you account for unconscious bias with respect to human-machine collaboration?
Interesting question. Unconscious bias. The answer I would give is I don't think you can. I'm certainly not a psychologist, so I don't know. Training would obviously be one way of doing it. And I don't know that you really can influence that, but again, perhaps you can. But I think another way to look at things is if the machine and human together can operate more efficiently a very large part of the time and prevent really bad situations from occurring, that's the benefit. And I think the benefits outweigh any unconscious biases. I haven't thought through that question in any detail. But I will ask some of the AI guys.
Other questions? There's one right here. Hold on. I got you.
Hey, Scott Biddle with TSYS. As we move from jumping back and forth to local devices and cloud devices or enterprise devices, private clouds and whatnot, what are we going to do about the databases that we're talking about are massive? And how can you jump seamlessly from a cloud database to a local device and without performance impacts?
Okay, question was about databases, and you're right, you're hitting on some key problems. There's no question about it. I mean, there are techniques you could use to split up databases. I was addressing more the splitting up of the logic, what runs where. And most of it is stateless, but not all. Some of it may have local databases. It's the same problem. You have to think of where do you want to put the data. And in some cases, it may be that the data is going to remain in the cloud, and that's where you want it, say, for security reasons. You're not going to move it to the edge, and you'll just access it through APIs on an as-needed basis. And then there are security issues and so on. I think the database problem is a big one, so not to evade that. But I think thoughtful design can avoid those problems. Replication is another way to do it.
Any final questions? Nope. All right. Thank you, Marty.
Thank you.